So on 47, it asks, what quantity of a 60% acid solution must be mixed with a 30% solution to produce 300 milliliters of a 50% solution? Alright, so we're taking a 60% acid, we're mixing it with a 30% acid to get a 50% acid. Okay? I usually make myself a table when I'm doing these problems. So this, I will have a 60% acid, 60% solution. I will have a 30% solution. And my final should be a 50% solution. Columns, I'm going to make two columns, one for the total solution, the total liquid in this case, and then the other will be a total pure, whatever the percentage refers to. In this case it's acid, but if you want a more general term you could also say solute, because almost all of these you're dealing with a solution. So solute is the thing that's dissolved in a solution, but in this case it's acid. So anyway, how are we going to do this? Well, first thing we're going to do is variable assignment. So they want to know what quantity of a 60% acid. So I will let that be X. I might use S, but my S's look a lot like my 5s, so it's better for me to do an X or a Y in this case. And they gave us the amount they want of the final solution. We have to have 300 milliliters of the 50%. I can actually write my 30% in terms of these two, because if this were Y, it's not going to be Y for long. I know I'm dumping this together with this to get this. So that means X plus Y equals 300. Well, that means I really don't need a Y as my variable, because I can just express that one as 300 minus X. So 300 minus X. In this column, which is actually going to solve our problem for us over here, I'll tell you why in just a second. Well, the total pure acid, I know 50% of this solution is pure acid, so 50% of 300, 0.5 times 300, 150, is how much pure acid I have in this solution. Well, in this solution I can set up expressions for both of those, because I know 60% of this solution is pure acid, so 0.6x. 30% of this solution is pure acid, so 0.3 times 300 minus x. The thing you have to realize is that just like this plus this equals 300, the total solution in one ingredient plus the total solution in another ingredient is going to be the total solution in the mix. Well, it's also true with the pure acid. If you take the pure acid in one ingredient plus the pure acid in the other ingredient, it's going to equal the pure acid in the result. That's just conservation of material. If you dump so much sugar in from one ingredient and so much sugar in from another ingredient, your total sugar is going to be the sum of the sugars in the two ingredients. That's just how it's going to work, unless you have some chemical reactions which change, the composition. But we aren't dealing with that. We are just mixing. So that means 0.6x plus 0.3 times 300 minus x equals 150. And that's an equation we can solve. that's an equation that's going to solve the problem, because what we were trying to find was x. So 0.6x plus, let's see, that would be 90 minus 0.3x equal 150. So take the 90 over and combine these two terms. 0.3x equals 60, and x would equal 200 milliliters. Because x is the amount of 60% solution, and that's what they asked for. 100 milliliters of 60%. If they'd asked for how much of the 30% we need as well, that'd be easy. You just take 300 minus 200 and you have 100. So 200 milliliters of 60%, 100 milliliters of 30%. Combine those, you get 300 milliliters of 50%. Let's do 48 as well. So this is 47, 48. What quantity of pure acid must be added to 300 milliliters of a 50% acid solution to produce a 60%? Well, let's see here. We're combining 50% acid with pure acid. So that would be 100% solution to get 60% solution. I really have trouble drawing straight lines on this thing. Total solution, total pure acid. Alright, in this one we are trying to find how much pure acid. So x for 100%, and I might as well fill this one in too. 100% of x is just going to be x. That's basically 1 times x. Total solution here, it gave us this 300. In fact, it's literally, I think, taking the result of last problem or taking the resulting mix of last problem and changing it back to a 60% solution. And 50% of 300 would be 150 again. Down here, well, here the x is in a different place, and remember we're combining this one with this one to get this one. So this one would just be 300 plus x. And then this one would be 0.6 times 300 plus x. And we have the same equation. This plus this equals this. As if I add the pure acid in one ingredient plus the pure acid in another ingredient, it's going to equal the pure acid in the final mixture. So 150 plus x equal 0.6 times 300 plus x. So that's going to be 150 plus x equals 180 plus 0.6x. Well, I guess I'll move the 0.6 over, so 1 minus 0.6 would be 0.4. As you know, I have 1x, 1.0x minus 0.6x be 0.4x. And move the 150 over, you have 30. So x equals 30 over 0.4. Let's see, multiply top and bottom by 10, I have 300 over 4, which would be 150 over 2, which would be 75. So the answer to this problem is I need to add 75 milliliters of pure acid if I'm going to raise the concentration of this 50% solution to 60. .75 milliliters of pure acid. And I'll just point out here, don't be confused on 49. This is the same problem. They only care about the concentration of gold in this one. They want to add, let's see, a 90% gold mixture with just adding silver, so a 0% gold mixture to get the gold down to 75%. So you set up your table with 90%, 0%, and 75%. And then the amount they give you is 5 rings, each weighing 18 grams. So 5 times 18 would be, I think, 90. And you plug that in and find your answer. So yeah, I think we'll look at 2 more problems. Work problems. Work problems are distance, rate, and time problems in disguise. So, on 55 here, sharing a job, Candy and Tim share a paper route. By the way, we're doing distance, rate, and time on these problems. So distance equal rate times time, our old formula. Candy and Tim share a paper route. It takes Candy 70 minutes to deliver all the apples, and it takes Tim 80 minutes. How long does it take the two when they work together? Alright, there's one big thing you need to know to solve work problems. Besides that they're distance, rate, and time problems in disguise. The other thing you need to know is that combined rate equals the sum of individual rates. So, if we have 2 people working on the same job, their combined rate is the sum of their individual rates. The easiest way to see that is to think about, say, 2 guys working in an orchard. One guy can pick, say, 5 buckets in an hour, 5 buckets of fruit in an hour. The other guy can pick 4 buckets of fruit in an hour. Together, they can pick 9. Their combined rate is the sum of each individual rate. So we're going to set up our information with Candy, Tim, and together. And I'm going to make a distance, rate, and time table. So I have the distance, I have the rate, and I'll say this is the work rate, and we have the time. So, they're all doing the same job. They're all doing one paper route. So that's the distance, or the work done. One route. One route. The time, well, we're given time for Candy. Given the time for Tim. For the other one, how long does it take the two when they work together? That's what it's asking. So I'll set that to be T. Some of my students would say, well, their combined time is going to be the time it takes them to do it together. But that doesn't make any sense. If I add their 70 and 80, I get 150. Why would it take them more than twice as long as Candy to do the same job that Candy could do in 70 minutes? They should work faster, not slower. And then the next students, they start guessing and say, subtraction then. No, that's too fast. It doesn't take them just 10 minutes. And then one particularly bright student might say, well, why don't I just half one of them? Well, that's closer to the idea. But which one do you have? And secondly, I mean, if they had equal times, if they both worked at 70 minutes, then yes, their combined rate would be half, because if you work twice as fast, your time is halved. But when you have slightly different times like that, the ratio is going to be a different result. So we need to just work this through. Combined rate is sum of the individual rates. The rate I can calculate. How do I calculate rate? I'll just take my equation up here, R equals D over T. And get my D to come through. D over T. So 1 over 70, 1 over 80, and 1 over T. Oh, not 10, T. Then what did I say? Combined rate is the sum of the individual rates. So that gets me an equation, 1 over 70 plus 1 over 80 equals 1 over T. Combined rate, sum of the individual rates. That's an equation? Not difficult at all to solve. Just clear fractions. Least common denominator is going to be, see, 7 and 8 both go into 56, so 560 T. So I multiply that through, 560 T, 560 T, 560 T. I will get, that'll be 8T plus 7T equal 560. So I get 15T equal 560. T equal 560 over 15. Well, I can at least reduce the 5's out of that. 5 into 560 would be, let's see, 112 over 3. And, yeah, 3 won't go in evenly into that. But, I mean, if you want an approximation for this, I mean, that is 37 1/3 minutes. I mean, this is what I would write for the exact answer. But honestly, on WebAssign, usually they ask you for an approximation. So for you, it would probably be 37.33. But it's slightly over 37 minutes. Which, if you think about here, your half of 70 is not a bad approximation. Half of 70 is 35. It took a little longer than that, though, because Tim didn't do the job in 70 minutes. He did it in 80 minutes. So it's longer than 35 minutes to do it together. So 112 over 3 minutes is the answer. And that's pretty much how you do all of these problems. The only difference between one problem to the next in a work problem is that they might give you the time together instead of the time apart. You'll still set up sum of individual rates equals combined rate. It's just one, or you might have your variable in a different place. But it's still solved the same way. You still clear fractions and then work from there. I think that's where we'll end this section today. That will be all of 1.5. I will see you in 1.6 when we talk about solving quadratic equations.